And we are live. Hi Shahir, how are you?
I'm good, Rahul. I'm doing fine. What about you?
Yeah, I'm great too. So, welcome to this interview for the intern role that we have for our 2025 graduates. And I hope you are familiar with what we are going to do today.
Yeah, I have a brief idea about it.
Yeah, so basically, I'm gonna take a technical interview of you. I'm Rahul. I've been working at Swiggy for the past 2 years. I joined back in 2022, and Uh, yeah, so I will be your interviewer today, and we will be having two coding questions. You have to manage your own time. I don't think we are going to have you make run this code, like run this code that you will be typing. Uh, it's all right. I don't think that will be a problem, but we will require for you to do a dry run of the code like in theory. And I think you can start by giving a brief introduction of yours.
All right, Rahul. So I am a SDE at a YC-backed startup right now, and I've been working as a professional for the last 1 year, and have done my graduation in BTech Computer Science.
Right.
I guess, yeah, that
Right,
should
that's
wrap it
cool.
up.
So we will be starting with the interview right now. It's currently 1:20 PST, and it's overall 45 minutes time. All right, I'll just paste the question for you. So for the first question, you are provided with two arrays. You're given two arrays. These arrays primarily contain values of nodes that belong to a tree, and
All right.
these nodes are ordered in form of uh, the first array is given in a form of uh, a pre-ordered traversal, and the second array is a post. Yeah, it's a post-ordered traversal, and you essentially you have to uh, return the tree itself, return the root of the linked tree itself. So basically, you're given the post and pre-ordered traversals of a binary tree, and you have to return a tree.
All right. So just quick questions. So I just like to confirm what the definition of pre and post order traversal here.
Right. So let's say if we are given a tree, right? So I'll just initialize a basic tree right here. We are given a tree that has two nodes. It's a definition of binary tree. And for the post order traversal, post order, we define it as like traversing the left child before the parent node. That is left, then we go to the right subtree, and then we return back to its parent. And in case of pre-order traversal, this makes it like we go to parent first, and then we do the left subtree, and then we go to the right subtree. It's just the order of traversal of the.
All right. So basically, it's left, right, root, which is a parent, and for the pre-order, it's root, left, right. Makes sense.
Correct.
All right.
And for your reference, I have attached a sample test case in the illustrations folder. You can check it out. So there we have a tree provided for you. It's a binary tree, and we have provided pre-order and post-order arrays. And then the output is basically it's an array written here, but basically you can only return the root of the tree itself, and we can consider it a valid solution if it returns a valid tree. Like the root that you return has all the valid connections to its children, right? I hope that makes
All right.
sense.
All right. So let me just restate the problem to you first. So I'm initially given two arrays, which gives us the pre-order and post-order traversal of a particular tree, right? And with this information, we have to build a tree itself, right? And and I would like to ask you what some edge cases that could be there. For example, the post or pre-order both can be empty, right?
Right.
Yeah, all right. So I have to deal with if both of them are empty, and I guess if they either one of them can't be empty, they have to be empty together, since
Yeah,
mostly
the
if
both the orders are essentially valid. So if a tree exists, both the order traversals will contain equal number of nodes, that is the nodes
all
present
right,
in tree.
all right. And how many nodes can we have here?
It's basically the number of nodes you can fit in a uh, integer integer bit.
All right, makes sense. So I'll just like to gather my thoughts first, right? So I'll just take the first sample that you gave right here.
Right.
Let me just write it down. So for the first example, the pre-order is 1, 2, 4, 5, 3, 6, 7. Right, and the post order is 1, 4, 5, 2, 6, 7, 3, 1. Right, and this is left. Okay, let me just pre-order. Makes sense. Okay, so here we are looking at the pre-order. So with this, I'm saying that uh, the leftmost element in the array of the pre-order is the root always, right? And in the post order, it's the rightmost element. So if in the given tree that you have given, I'm trying to notice if there is a pattern which in with which we can generate the left subtree and right subtree of a node, right? So since this is a pre-order, right? So I'm assuming this is start and this might be okay. This is the root, right? So some of the elements here would be the left belong will belong to the left subtree, and some of them would belong to the right subtree, right?
Right.
So again, okay. So all right. So let's say I take the pre-order itself, right?
Hmm.
So I create a tree with the leftmost element. Then I have to find its left and right child. So how would we do that? So yeah, mm, I'm just thinking along the lines. Okay, according to diagram, the three is the right subtree, and the left subtree with starts with two, right? So how did we decide that? Okay, the right child will come exactly after two places. How did we come to that? All right. Hmm.
Okay, Shahi, I think you are kind of on the right track by noticing trying to notice a pattern in these both arrays. As you mentioned, like the first uh, the first node in the pre-order traversal is always the root. I think that's pretty accurate observation. And I would just uh, if I would just try to find out the maximum amount of information that I can get and derive from the contrasting other array, right? So
Yeah.
basically, like you also pointed out, the uh, rightmost element in the post order of the array would be the root, like they will be identical. So that's given for the current level or current node that you are at, right? So basically you are
Yeah.
eliminating, essentially eliminating some nodes for every step or every recursion you are letting going down.
Yeah.
So
Right.
like you are dividing this tree into subtrees, if that makes sense.
All right. So let's say if we take the uh, one as the root, right? So I'm just checking. Okay, so the next root, if I take, so the left and the right subtree belong here, right? So I'm just trying to see if I can divide the pre-order and post-order in such manner that at each step we have like a particular segment belonging to a particular subtree. For example, here we see pre-order has this as the left and right, and child. So let's say if we take two and where do we find post order? In post order our two is at the second index, right? So it's the parent, so its left and right belongs here. And all right, I think I'm seeing some kind of pattern here, but again it's going again in the one-sided direction. I'm trying to find how do I look for a pattern where I'm able to see the right side as well.
So Shahir, I think you can go over the illustration once again. I think you can see pretty here that uh, basically at each node there's always two children present, right? So it's a balanced binary tree, or like you can say a full binary tree, right?
Yeah.
So here you can pretty much observe that there is always a clear distinction that you can draw between left and right subtrees. I would I would think, what if one subtree was absent for any node? What would be the case then? Like what would be the pattern that pre-order and post-order would follow if one subtree for a particular node were absent? Like would they still be able to distinguish that a left or subtree is, like how would we derive if the next node in the pre and post-order traversal is the left subtree or the right subtree? Like here it's pretty clear, right? So what if one subtree were absent?
Mm, all right. Okay, maybe I'm seeing some pattern. For example, let's say if you take one, right, and here it's if you were to find its right child, we can check the one adjacent to it here. So one has the right child as three in the post order. We can check from the post order, right? And the if you are to find the left child, we will look at the element to its right in the pre-order, right? And again for two, I guess, okay, again for two, we can. check. Okay, if you were to find the right subtree, we will. It's just adjacent to the left in the post order, right? And if you were to find the node, let's say, if you were to find the left subtree, we will just check in pre-order. So it's the edge to the number to the right is 4, so it will be in the pre-order. So it will be this left subtree will have 4, and again for 3 we can just do uh, for 3 we can just check and post order what's adjacent to it. It is 7 in the post order, and for the left subtree we can just find pre-order its position in the pre-order, and we can just check the element to its right. So it's 6, I think. And let's say if you were to find the right subtree for 7, I mean, we'll check this non 3, which is its parent.
So I think you're just okay. All right. So your approach revolves around uh, assigning the adjacent elements with the pre-order for the right subtree and for the left subtree, post order of the left subtree, right?
Yeah, something like that.
Okay. Okay. So
But I'm again saying, if let's say if I come to 7, right, how do I decide that it's
yeah, exactly. So
I think
basically,
we can.
if it's a leaf node, or if any of its subtree were absent, so how would you like clearly distinguish that, realize that it's added of the tree?
All right, 6. What can we do here? Can we keep some kind of visited array just to keep try? Okay, this we have already used 6 here. So if any element addition to it has already been marked, doesn't mean we cannot take it. We cannot create a left or right subtree. I think thinking along that line.
Okay.
So, for example, if I'm at 3, I build 6, right? Then I'll
So
build the right
let me
subtree.
just go through the approach once. So basically, at each level, at each root that you are given, each node you are given. So basically, if you were at the first node, right? So if we're at first node, you could easily get the right subtree by just going +1 index of the uh, -1 index of the post order. That's how you
Yeah,
find the 3. And for the left subchild, you are like just pushing 1 index ahead of it, right?
yeah.
So how exactly do you plan to terminate this recursion if you're doing that? I don't know. Like how are you dividing this array? How do you know that you have completely exhausted all the nodes that are present ahead? Is there a check for, like, do we even traverse the whole tree this way?
I can. I was thinking if we can have a visited kind of set here. For example, if I was at 6, right? Let's say if I were to find the left and right child of 6, right?
Okay.
So we can say if I look to the left of it, uh,
So in the, like,
the
or
2 is already been
so when
marked.
you are already at 2, right? So you have arranged one node's left and right subtree correctly, and now you're at node 2. And now for the pre-order traversal, since you took the first uh, 2, like this +1 index, so I think you can maintain the pointer pretty in constant time, so you just take ahead 4. But how do you exactly come to the post order traversal of this current node?
I can have a hash map to keep the keep the track of index of particular element in the post order, right? So let's say I can create a hash map, so I'll know at which index 2 is in this post order array, right? And about terminating condition, I think we can keep a map for visited, right? So let's say if when we create node, like let's say we created two, right? We can mark as visited. So let's say for a particular node, if I'm checking the left node, the node left to it, if it's present, right?
Right.
Then if I check, okay, if this element has been visited, we do not call the left subtree through recursion, right? So this way, and for the same for the right, if let's say if I look for the right, maybe it might already been visited or not. Let me just check. Yeah, so for here 6, for 6, 7 might have. All right, so we're looking to the right when we're doing checking pre-order, right? 5, the left subtree. So if you're creating 6, then and we have not created 7, let's say, since you're going in a depth first search, how do we deal with that? Okay, and right. Okay, maybe it works for maybe either one of the uh, adjacent element in the post or period of a current node has been visited earlier. This means we cannot move further. So we won't call any recursive. We won't call the recursion from there. So it will actually terminate from there only.
So how many hash maps are you planning to keep for this bookkeeping thing?
I think we can keep 2 hash maps. One for keeping a track of element in the post order, right? And one for keeping the visited array.
And what if uh, similar values were present in the nodes?
Okay, the hash map can be of the type tree, the tree structure node structure, right? Instead of I'm doing a map of tree end comma end, I can do have a map of uh, tree node, right? So it will actually
Right. So the
have the
complexity
inequality.
for this algorithm that you're talking about?
It will be the time complexity will be O of n, where the number of nodes is n, and the space complexity will be 2n, or n. We can consider it O of n only, since we are creating a map. Auxiliary times space complexity will be O of n, since we are creating 2 hash maps
All right.
during the process.
Yeah, I think that works. I think that works. So we can go ahead and code it up.
All right. So okay, should I create a CPP file here for better indentation, or
Yeah, you can just create a temporary CPP file, and don't worry
okay?
about some boilerplate. You can just declare your function yourself and just start returning.
Okay, can you give me if like know if what will be the structure of the
Okay,
tree node
so
class?
you actually have to define the tree node class yourself. You just need to make sure that it contains all the relevant uh, properties. That is,
All right,
yeah. So its value, its left pointer and the right pointer. Yeah.
all right. So left, right. Okay, so I have created a tree node structure here, where a particular tree node can have a value, and it can have a left and right child, and this is the constructor. So let's say if you want to create a new tree node with a particular value, this function will be called here. Defining tree node structure, right? And okay, let's say I'm given make tree. I'm giving a pre-order array and a post order, right? So here, let me just see. So I can have a hash map for storing the position of particular tree node. Yeah, tree node index map, and we can have another hash map for visited, right? So visited map, right? So I'll just quickly go and initialize the value of each element. Oh wait, okay. Yeah, if they have the same value.
I think for simplicity, it's you can just assume that they all have unique values.
Okay, so post order array. So here, index map will have post or of I. Yeah, so this way we can initialize value, and let me just make it global only, so it will be easier to access later on, right? And now we can, okay, we'll have to return the root node, right? So we can make it of type tree node and return build tree, and you'll pass the pre-order and post order to it, right? So train, it will be of type, the build function will be of type tree node, and it will take these two arrays only, post order and pre-order. And we can check for the root, we can create a tree node, right? Tree node root is, it will be a new tree node, and we will create it with the leftmost. Okay, we'll have to keep the index as well, right? Okay, index, we'll have the index of the root. For the first case, it will be 0, pre-order of IDX, right? And we will mark it as well as we make as the create node, will also mark it. So order of period of IDX 1, and we can obviously return the root key that we have node we have created so far. And here we will decide, okay, how do we create the left and right child, right? If visited of, okay, if the index is greater than 0, right, then we will call according to our logic here for pre-order. The pre-ordered array will take the right element to this right as the left subtree, right? So can have root left subtree be like this. It's less than, okay, should be less than uh, pre-order dot size minus 1. So it will be adx plus 1 pre-order post order, and then map of is equals to 0. And else again for this is for creating the left left subtree of current root node, and this is okay. Okay, you have to check if either of the left subtree right tree is case. Oh, a particular node is already not visited. If either one of them have the node as visited, we will not go further with any of these. So let me just do this here. 1 second. I can have a check. Okay, let me just work with right subtree for now. Greater than 0. Yeah. Of
I
RDX.
think that's enough for now, Shade. I think we are running out of time. I think we are much better off if we like give you a shot with the second question.
All right.
So you can come back to codepad.txt and I will just give you the second question. All right, so for this second question, you're essentially given a string. This string can be, it only consists of lower case English letters. So that's lowercase English letters, that is alphabets only. And this string is basically anything, right? So it could be ABCA, and you have to return uh, objective goal is to uh, basically get the longest substring that is a basically that is a valid almost palindrome, right? So basically I hope you know what's a palindrome is. So a palindrome is basically anything that you can reverse and it stays the same. So ABA is a palindrome. And what do I mean by almost palindrome? Is that basically for the string that you are checking in for, if it's a valid palindrome, you can basically delete one jar from it and it will still be considered as a valid palindrome, right? So basically for the above example that we are given, it's ABCA. So as you can see, if we delete one character from this, it could be ABC and it becomes AC or ABA. So that's a valid palindrome. So you return for the above example, it's 4, since the length of the whole ABA string is ABCA. So that's 4, right? So that's almost valid palindrome. Yeah.
All right. So Again, I would like to restate the problem to you, just to confirm that I understood the problem right. So I'm initially given a string, right? And the objective of the problem is to find the longest substring, which is a valid almost palindrome. And by almost mean we are, let's say if we have a particular string and we are allowed to delete one character at max, so we'll have to return the uh, length of that particular substring.
Right.
All right. So, uh, is there any edge case? For example, the string can be empty.
Yeah, the string can be empty, and the maximum length of this string is basically yet again just a built integer length.
All right. Maximum length can be, and we are only dealing with lowercase English letters. Cool. So, let me just think on along the lines. Let's say if it were uh, a problem, let me divide it into a much simpler subproblem first. Okay, if it were a problem about talking about we had to find the longest substring that is a valid palindrome, how we cou- how we would solve it. And I think maybe you can think of along those lines, and maybe might be able to find with the answer for this one with a slight adjustment where we can delete one character.
Yeah,
So
so I guess in fact we can just reduce the length of this string to a value like uh, 3000. Yeah, I think 3000 works. So you can assume that it's not actually 10 to the power 5 or 10 to the power 7 length string, it could be just a
all right,
3000 length string.
so if I were to find the longest uh, palindromic substring, say we given, right, what I could do, since the palindromic substring has a property, wait, let me just, if a string is a palindrome, the uh, elements uh, from the center, and if we move in two directions from center to the left and from center to the right, let's say in a particular substring, all at each point we'll find that, okay, in the first half and the second half, the all of the strings match, every character is the same. For example, here, if I were to take a, right, this is a valid palindrome. So if I were to take b as its center, since the, right, if I were to move from center to the left and find if you were to check this position and the position from center to right, it has same character. You can see actually the leftmost part and the rightmost part is actually identical. So what if we do this, we treat every character in the string as center, right, of a palindrome, a possible palindrome, and from there we can iterate in we can expand our array in towards the left and the right at same pace. So, and if at particular time at a particular uh, index, the left and the right character do not match, then we stop there and we can return the longest substring we find for that particular uh, substring, right? And we can do this with every consuming every character in the string as the center, and then we can keep on expanding, and we can always have external variables for storing the longest substring with palindromic substring we could find so far. And I think this is since we are doing it for each character and we are expanding in O(n) fashion for each character from each position, I think it will have a time complexity of n square and a space complexity of O of 1, since we are not storing anything while the program runs. The auxiliary space complexity will be O of 1
So that's
for a
that
valid
works
palindrome,
for
right?
a valid palindrome. Yeah.
Yeah. So let's say, for example, okay, if we had to, all right. Okay, let me think along the lines. So let's say if we are given a condition that we can remove uh, an element, right? So if we were allowed to remove one element, so we didn't find it, can we recursively uh, we can assume we can skip that particular index and start from there? Can we do that? mm, I think we can. Okay, so for, let's say if we are allowed to skip uh, a particular index, right? Let's say if if it does not match, for example in ABC, we are expanding from B, right? So we see, okay, A does not match C, so we can just increment our right pointer uh, to the next by +1, right? So it will be here, and from here we can check. From here we can recursively call the same function which was trying to find the longest palindromic substring, and with the check will also pass a variable called has deleted, maybe, to know that okay, we have already deleted once, so that next time we find another character which has not been matched, we do not recursively call it again, so it will be called once only, right, after we have skipped the character. So does that make sense?
I think so, but I think I would like to draw your attention towards a case like, uh, so basically this is a valid palindrome and this is also a valid palindrome. Yeah,
Yeah.
I think you would agree. So
Yep.
what's the difference between these two palindrome, or like in the
Yeah,
in the
so
way you're checking, right? So
again, obviously, since we are assuming every character as a valid as a center, right?
mm-hmm.
So a palindrome can be of even and a odd length, right?
Right.
So let's say if it's even, then we can assume the center is somewhere between here, these 2 points, right? So we will keep the left pointer here and the right pointer here. And if, let's say, if we can also consider a point that the current character is all this is the center itself, so we can keep the right pointer here and here instead.
So
So
like, are you saying you will maintain a ghost point or some sort?
yeah, we can have two cases, right? So let's say if let's say check palindrome, let's say you have a function, right?
Mm-hmm.
So we'll pass it the pointer and right pointer to check the left side, to match the left side with the right side from a particular position, right? And
Right.
expanding those direction. So let's say if it's a even length, the palindrome. Let's say if we consider a case, it produces from particular position, it produces an even palindrome. We can just give it a left pointer this, and we can give it a right pointer as this. And if it's odd length palindrome, we can have check palindromes. Start with the can start with the same index,
Yeah.
which is
Yep. I think that's fine. Yeah.
right. So
And what
again,
will be the time complexity for this?
the time complexity will be of will still remain of n square, since okay, within we are in the same loop, we are just calling it twice, right? So it will be 2 into n square, 2 n into n, it was, which will just of n square only. So the time complexity will be uh, 2 into n, right? As I said earlier,
Right.
which is uh, almost equal to of n
Yeah, I
square.
think that's fine. I think you can just
Space
start
complexity
coding this
will
out.
be of. All right. So
You can just create a new file for this.
I can just create a start at the bottom of the previous file I created.
Yeah, you can do that also. That's fine.
Okay. So let's start coding here. Let me just. paste the problem so that I don't have to go back and forth. Right. So I can assume that I have a function called find longest palindrome. Palindrome, and it will give us will given a particular string, right? You can have string s given to us, right? And again, we have to return the period of type int, since we have to return the length of the longest string. All right. Recurs. All right. So what I can do is, for, as I said, we will look at, we'll start from, we consider every character as a center, right? So I'll just loop through the each character in the string. So let's say for a particular character, and we also will maintain an answer variable just to store the maximum answer so far. So we can have answer is max answer, and let's say if we consider, we start with the considering even the even length palindrome can be generated from this particular center, right? Even length palindrome, and we can check start from here, check palindrome. Since even length, we can start from I plus 1, and we can pass it s, and we will pass it a flag of 0, since initially we have not deleted any character, right? Again, we can do the same for our length 1, but here the center will start from I comma a only, right? And at last we can return answer. Now I'll just go ahead and write the check palindrome here, right? So, and check palindrome, it is given the left pointer, the right pointer, and given a string s itself, and bool has deleted, right? And here we can, okay, at last we can just return the right pointer minus left pointer plus 1. Okay, cool. Okay, so what we'll do is, if we'll iterate, I will move our left and right pointer in this fashion, where left pointer will move to the left till it's still greater than equal to 0, right? And right is still less than s dot length, right? Okay, if all right, cool. So if s of left is not equal to s of right, means we have found the first character which is not matching here, we can call check palindrome itself, and if also we will call only if has deleted is 0, which means we have not deleted a character yet. Here, check palindrome of left or right plus 1, and pass 1 here. Else, if it's not, then we can, if it's already 1, then we can just return, you can just break from the loop, right? Otherwise, you can just decrement the left pointer and increase the right pointer. That sense. All right. I think can I just add some comments and in the end. So move the left to the left till greater than equal to 0 and the right is less than n index. And if we and if we encounter that uh, element at each pointer pointers aren't matching, we can call the same function recursively with hash deleted set to 1 and incrementing the right pointer to
Okay, Shahi, I think the comments are fine. I
1.
think can you now do a dry run with the code that you have written? I will just give you an example right here. So let's say you're given a string that is mm, mm, yeah, how about this?
Okay, can you please remove your cursor from it because it's blocking the
Yeah, sure.
characters here. Okay, so for this we know the longest we can have is length
Actually,
3.
just add one a also. Yeah, I think that's fine now.
Okay, so for this we can have the longest so string as okay. So the answer of this, let me just confirm, is 1 2 3 4 6, right? Answer for this test case should be 6.
Yeah,
All right. So again, since we know I'm if we do manually end up doing it for each character, it will take a lot of time. So I'll just start from uh, the center, which will actually will give us the correct answer instead.
yeah,
So I'll
sure.
start with
Okay.
B, right? So again, we can start with we can call this check palindrome from. Let me just write the indexes or okay. What's the index of B? 0 1 2 3 3. Okay, and okay, and we can have the left pointer to be 3 and right pointer as index 4, right? So again, we'll go to the check palindrome, right? And hash deleted is 0, right? So we'll go to the check palindrome and we'll actually move the left and right pointer till we have seen that okay, we since our characters are matching at each pointer's position, right? So we'll check okay. So for third and A and B actually don't match here, right? So A and B do not match. So and since our hash deleted is 0, we actually call check palindrome again with these new pointers. So has we skip the character A and move to move right pointer by 1, right? And we can so now the left pointer is still at 3 and right pointer is at 5, right? And we come to the check palindrome and we come inside the while loop. We check okay, still the uh, elements are not equal, so we'll break from the loop, and our right point left pointer is just is 3 and 5, so it will give us the length as 5 minus 3 plus 1, 1 which is 3. Okay, it should be actually should give us 2 instead, since we okay, is it? It should give us 2 instead, so I'll correct that here. Left it's right minus left minus 1, so it will give us 2. Yeah, only.
Alright, right. I think that's well and good. I think we're pretty much over time. So, any further questions you want to take ahead, or should I just provide you with the feedback?
Yeah, sure, you can start with the feedback.
So, Shahir, I have actually, I think it's pretty evident, right? So, you couldn't even come up with a solution for the first thing, first question, and for that only, I think you get a pretty solid no higher, and even for the second one, right? So, you did come up with a solution, but you, I think, yeah. So, in the second case, you were like a pretty, you were stumbling very much in the test case in the dry run as well, right? So, I think I can start with the second question. So you can just come to the code.cpp if you can see my cursor. I think the code that you have written is pretty fine. I think you just missed a pretty important observation that basically if you were to delete the current char, right? So you have to delete the current char. So basically, you like just like here for the even and odd palindromes, you do a double check here. So basically, you could do right plus one, or you could basically this should be, I think, can just store it in a variable for check one, and you can do a variable here check two to just add some syntax in here, right? So let's not focus on syntaxing, right? So basically you have to do another check here. So basically left plus one and right, if that makes sense. So like in this case as well, I think you end up a right solution if you start with C. Basically you consider C as a valid palindrome. You'd like do it do a palindrome for odd number of lengths, right? So you delete the B part and you move on to A, and it's just ends up at the strings and corners. Same goes for B. I think you end up a right solution here, but I don't know if it's very correct. In long-term cases, you have to take the edge very seriously. So I think that was the key observation that you missed. And for the first question, you can come back to code guide. And so basically, I think you missed the key observation again. So basically, you do know the property, right? So basically, if in order traversal is present and any else order is given, basically in order plus pre or in order plus post order, you can construct a unique binary tree with that. But in case a post and pre order is given, there it doesn't always basically you can't produce a valid tree, right? So you can't always produce a unique tree, and that's why I was pointing to you that what if root was missing any subtree, right? So basically
Yeah,
in that case, if it were missing subtree in the first case itself, you can see its pre would be 1 2 3, and its post would be 3 uh, 2 3 1, right? But just remove one and see what you get. So basically if we remove 3, now we have 3 and we remove this, so we basically get 1 and 2. So this is correct for the current tree, but what if 2 were present on the right node, right? So what if original tree were like 1 and 2, still like the pre and post doesn't change, like if you get the point.
yeah.
Yeah, so that was it. That's not an
So
issue.
basically, we there was no right solution for this. We cannot create a.
No, you can basically there are multiple solutions to this, and that was part of the problem that if you had asked me like can I return any solution that is present, and that I wanted, so you can produce a valid solution. And for that I think you got around a pretty uh, clever way, I would say. I think I still need to check if that works in practical implementation though. But yeah, so there is I think there's a better way. Basically, you use divide and conquer to divide these trees into basically left and right subtrees at each step in a recursion. and I think that's pretty that's better way, that's more modular and easy to understand. But
Yeah.
yeah, I think yeah, you do need some practice on the part of uh, uh, coding, and like just knowing the theory, I would say, like some soft knowledge about these concepts. I think that would go a long way. uh, I just focus on some theory. And for this later part, I think your coding in C++ is pretty good. You do have the right grasp on the struct and syntax and all of that. Uh, though we didn't even get to the part where you care for the edge cases, like expecting a null value or other things. But
Yeah.
yeah, I think that is taken care of. So that is all. Any other questions?
Mm, nothing as such. Thank you for having me.
All right, that's fine. Have a nice day.